On that dark day, in 212 BC, blood flowed in the streets of Syracuse. Roman legionaries were plundering the city. The resistance had ended. But in one house, an old man was still occupied with geometric shapes on the ground. While war cries rose around him, he was lost in the circles he drew on sand. A Roman soldier approached him, drew his sword. Without lifting his head, the old man said, "Please do not disturb my circles." These were the last words of one of history's greatest geniuses. Archimedes, the Einstein of the ancient world, the man who made discoveries that could not be surpassed even 1,000 years later, thus closed his eyes to history. Tonight I will share with you the incredible story of the ancient age's greatest scientist, Archimedes. This man was not just a mathematician. He was a legendary genius who discovered the laws of physics, created engineering marvels, and invented war machines that would even make the Roman Empire tremble. His story is a fascinating epic that pushes the limits of human intelligence and reaches the pinnacle of science in the ancient world. If you love the great geniuses of history, the scientific miracles of ancient times, and stories that push the boundaries of human intelligence, don't forget to subscribe to my channel and turn on notifications. If you're ready, let's dim the lights and dive into the magnificent world of the 3rd century BC, into the epic life of Syracuse's greatest son. Born in Syracuse in 287 BC, Archimedes was the child of a family with one of the brightest minds of the ancient world. His father, Phidias, was a respected astronomer and mathematician. When little Archimedes was still a child, on nights when his father studied the sky, he would sit beside him and watch the movements of the stars. These early observations had planted the first seeds of his scientific curiosity. Syracuse was one of the most important scientific centers of the Mediterranean at that time. The Hellenistic world, established by Alexander the Great, was experiencing its golden age in science and art. Archimedes grew up in this intellectual atmosphere, encountering new discoveries and new ideas every day. He spent hours in the city's great library, studying the works of old masters like Euclid, Apollonius, and Hippocrates. His extraordinary intelligence had been remarkable since childhood years. When he was only 8 years old, he was solving complex geometric problems, practically playing with numbers. His teachers described him as a wonder child. But what set Archimedes apart from other children was not just his intelligence, but also his endless curiosity. He wanted to learn how everything worked. When he was 10 years old, he made his first invention, a small steam engine for toy ships. This simple device rotated small propellers using the power of water steam. This invention was an early indicator of his practical engineering talent. Even as a child, he had a unique ability to combine theoretical knowledge with practical applications. In his youth, he went to Alexandria, that magical city which was the Harvard, Oxford, MIT of that time. The Library of Alexandria housed all the knowledge accumulated in the world until then. 700,000 scroll books, papyrus, and parchment were preserved here. Archimedes practically got lost in this treasure of knowledge, spending his days reading and researching. Eratosthenes, whom he met in Alexandria, became his closest friend and scientific rival. The two would solve mathematics problems together for hours, conduct physics experiments. While Eratosthenes calculated the circumference of the Earth, Archimedes continued his own research. This competition developed both of them even more. During his education in Alexandria, Archimedes acquired deep knowledge in mathematics, physics, astronomy, engineering, and even medicine. But what set him apart from other students was his ability to combine different disciplines. He used his mathematical knowledge in physics problems, proved engineering solutions mathematically. After returning to Syracuse, his real working life began. His first major project was to improve the city's water system. Due to Syracuse being built on hills, there was a water shortage. Archimedes designed a revolutionary system to solve this problem, the Archimedean screw. This invention was a simple but ingenious solution. A screw system spirally wound inside a hollow tube could pump water from bottom to top. The system worked so effectively that it began to be used not only in Syracuse, but throughout the Mediterranean world. This system, used in Egypt to carry the waters of the Nile to the fields, had created a great revolution in agriculture. Then came that famous bath story. King Hieron wanted to know whether his crown was really made of pure gold, but it was not possible to melt and analyze the crown. This problem made Archimedes think for days. He could not find the solution. One day, while entering the bath, he saw the water overflow, and suddenly a lightning struck his mind. If he immersed the crown in water, as much water as the crown would overflow. If he also immersed pure gold of the same weight in water, if the amounts of overflowing water were different, it meant other metals were mixed in the crown. Shouting, "Eureka!" he rushed naked into the streets. The people thought he was crazy, but Archimedes had discovered one of the most important laws in the history of physics. This discovery not only solved the problem at that moment, but also revealed the law of buoyant force, known as the Archimedes principle. This principle is still used today in countless fields, from ship design to submarine engineering, from balloon flight to the aviation industry. His work in mathematics was truly groundbreaking. He developed a method to calculate the value of pi, and proved that this number was between 3.1408 and 3.1428. This calculation was so precise that it had an impressive accuracy rate even by today's standards. For this work, he had developed the method of approaching a circle by using polygons with many sides. His discoveries about the sphere and cylinder were examples of mathematical genius. He proved that the volume of a sphere is 2/3 of the volume of the cylinder surrounding it. This discovery was so important that he had this geometric shape engraved on his tombstone. This work was one of the first serious mathematical studies that laid the foundations of integral calculus. His work, called The Sand Reckoner, was one of the most impressive studies in the history of mathematics. In this work, he had tried to calculate the number of sand grains in the universe. For this, he had developed his own number system, because the number system of that period was not sufficient to express such large numbers. This work was the first serious mathematical struggle with the concept of infinity. His inventions in the field of engineering had amazed the ancient world. Thanks to his work on pulleys and levers, he had shown that it was possible to move great weights with very small forces. The saying, "Give me a fulcrum point, and I will move the earth," was said during these discoveries. This was not just a showy statement, but a real engineering fact. When King Hieron asked him to prove this claim, Archimedes organized a magnificent show. He moved the largest ship in the harbor alone, with a complex pulley system. This show enchanted all of Syracuse. People came to see this miracle. Thus Archimedes laid the foundations of mechanical engineering. His work in the field of optics was also groundbreaking. He had experiments on directing light rays with mirrors and lenses. Thanks to these studies, he had discovered that he could light fire by focusing sunlight. This discovery would be very useful to him later. He also had important contributions in astronomy. He had developed a model explaining the movements of planets. This model was laying the foundations of the heliocentric universe theory 1,800 years before Copernicus. But these works were not taken very seriously at that time. When the Second Punic War between Carthage and Rome began in 218 BC, Syracuse found itself in the middle of this war due to its strategic position. Initially, Syracuse was in the position of Rome's ally, but after the death of King Hieron, his grandson Hieronymus, who ascended the throne, changed sides after Hannibal's impressive victories. This decision determined Syracuse's fate. Rome decided to punish its former ally, who had betrayed. In 214 BC, a powerful Roman army under the command of General Marcellus began to besiege Syracuse. It was at this point that Archimedes assumed the role that would change the course of history. Archimedes designed incredible war machines for the defense of the city. His first invention was the claw of Archimedes. This giant crane system would catch approaching Roman ships like a giant hand in the water, lift them into the air and throw them back. Roman sailors could not believe it when they first saw this weapon. How could ships rise into the air? The system worked like this. Powerful cranes installed on the walls would lower giant hooks attached to long chains. These hooks would attach to the decks of Roman ships. Then the cranes would engage and literally lift the ship into the air. After the ship swayed in the air, it would be released, shattering as it fell into the sea. The second defense system was giant catapults and trebuchets. But these were not ordinary catapults. Archimedes had made perfect trajectory calculations with mathematical calculations and had adjusted each shot so it would not miss its target. Roman soldiers could not believe the precision of these weapons. The most surprising defense weapon was the death ray system. Using hundreds of shiny bronze mirrors, he could focus sunlight and burn Roman ships. Although this system is legendary, modern experiments have shown that such a system could theoretically be possible. Archimedes' optical knowledge was at a level sufficient to realize such a project. When Roman soldiers saw these weapons, they panicked. Screams of "Archimedes is coming" rose from the ships. Soldiers were afraid to approach from the sea. The situation on the land side was not much different either. Archimedes had also developed special defense systems against land siege. With the lever systems he installed on the walls, he was toppling approaching Roman ladders and siege towers, throwing large stones precisely. Roman commander Marcellus once complained, "This geometry monster is mocking us." The most impressive aspect was that Archimedes had designed and produced all these defense systems largely on his own. He not only had theoretical knowledge, but also extraordinary practical engineering ability. He had specialized in every field from metalwork to carpentry, from crane construction to optics. The siege lasted 2 years. Throughout this time, Archimedes was constantly developing new defense systems. He was producing a new answer to every Roman attack. Roman soldiers were now afraid to approach Syracuse. The intelligence of a single man had left the world's most powerful army helpless. Marcellus eventually gave up open attack and switched to the tactic of condemning the city to starvation. But Archimedes had found the solution to this too. He was digging secret tunnels and having food brought from outside. He was even conducting raids on the Roman camp using these tunnels. During this period, the most interesting aspect of Archimedes' character emerged. Even in all this war hustle, he was continuing his mathematical studies. At night, he was solving geometry problems, developing new theorems, as if what was happening in the outside world did not concern him at all. In 212 BC, the event that changed the situation was a festival inside the city. The Syracusans were celebrating the festival of Artemis, and security had relaxed. Roman soldiers took advantage of this opportunity and infiltrated the city. Now street fighting had begun, and the fall of Syracuse was inevitable. General Marcellus had given special orders that Archimedes should not be harmed. He respected this great intelligence and wanted to take him to Rome and employ him in his service. "This man is very valuable. Do not touch him," he had instructed all unit commanders. But on that last day, Archimedes was at home, occupied with mathematics as usual. He had spread sand on the ground and was drawing geometric shapes. He had a new theorem in his head, about a cylinder inscribed in a sphere. He was trying to solve this problem. The chaos outside, war cries, sounds of plunder did not concern him at all. When the young Roman soldier entered, he did not know who the old man was. Perhaps he was looking for valuable items, or perhaps he was just checking if anyone was in the house. Without lifting his head, Archimedes said in Latin, "Please do not disturb my circles." These words were like a summary of his life philosophy. The soldier probably thought this old man was an ordinary citizen. Perhaps he did not understand Latin. Archimedes said the same thing again, this time in a slightly harsher tone. The soldier became impatient and swung his sword. Thus, the greatest genius of the ancient world lost his life while trying to protect his geometric shapes on the ground. When Marcellus heard this news, he was very sad. He punished his soldier for not obeying his orders. He organized a magnificent funeral ceremony for Archimedes. He had the geometric shape of cylinder in a sphere, one of Archimedes' favorite discoveries, engraved on his tombstone. This symbol was the last gift of his love for mathematics. Archimedes' death was a great loss, not only for Syracuse, but for the entire scientific world. His works were collected, copied, and tried to be preserved. But many works were lost at the end of ancient times. In the Middle Ages, Islamic scholars preserved his works and translated them. During the Renaissance, Archimedes was rediscovered. Galileo was greatly inspired by reading his works. Newton's work was largely built on the foundations laid by Archimedes. Leonardo da Vinci was influenced by his engineering studies. In the modern age, Archimedes' influence became even more evident. The calculations used in NASA's spacecraft are based on the methods he developed. In the design of nuclear reactors, in the construction of skyscrapers, in submarine technology, we can see his principles everywhere. Most importantly, Archimedes had laid the foundations of the scientific method: observation, hypothesis, experiment, conclusion. This cycle was his working system. This approach forms the backbone of modern science. His Eureka cry still echoes with every new discovery today. Archimedes' story is proof of the limitlessness of human intelligence. He had made discoveries 2,300 years ago that would suit the modern age. His curiosity, determination, and passion are a source of inspiration for all scientists. Perhaps his greatest legacy is this attitude of never stopping learning until his last moment, never giving up the ambition to solve the secrets of the universe. So, friends, this is the fascinating story of Archimedes, the Einstein of ancient times, the immortal hero of science. This legendary genius who reached the pinnacle of human intelligence shows us that with curiosity and determination, it is possible to accomplish the impossible. Dear viewers, I hope you enjoyed this epic story of Archimedes. If you liked the video, don't forget to like and subscribe to my channel. Which great genius's story do you want to hear in the next video? Write in the comments. Until then, take care of yourselves and never lose your curiosity.